Witte considers the installation of an elevator as a sequential assembling process of elevator subcomponents. It is for this reason that the parts of Witte's elevators are carefully sorted and supplied in modules. By module, we mean the group of components which, once assembled, carry out a specific function within the complete elevator. Each module can be made up of one or more packages. These packages are identified with a description of the module and its position within the assembly sequence. The supply of the elevator has been designed to fit what we consider to be the logical assembly sequence of a machine roomless elevator. The package that we have to open first is labeled and easily identifiable. Attached to this package, in a protective plastic cover, is the packing list and a document which details and lists the material supplied in each of the various modules. In this first package, we can find the assembly manual of the elevator and all the assembly handbooks of the individual components. Before starting the assembly process, we strongly recommend that the assembly technicians read all the manuals in detail. The assembly of the MRL-W line starts by checking that the conditions of the shaft, dimensions, cleanliness are satisfactory and that all the necessary material and auxiliary tools are available on site. The guide rail sole plate must be correctly positioned and levelled according to the assembly manual. The bottom portions of the car and counterweight guide rails are cut and assembled according to the installation drawings. Should there be a difference between the pit depth given in the installation drawings and the as-built depth, the bottom guide rail can be adjusted and cut to the right length. A tool to help align the guide rails is recommended in order to guarantee a correct assembly. Witte can supply a guide rail alignment kit upon request. The first row of guide rail supports is assembled. Their position is detailed in the installation manual. With the help of some scaffold platforms, the successive guide rail portions, 2.5 meters or 5 meters, are assembled with their corresponding support brackets. Once the last section of the counterweight guide rail has been assembled, the topmost bracket can be fixed into place. The last portion of the car guide rail fixed to the bed plate is assembled once the machine support has been installed. Alternatively, the process of assembling the guide rails can be carried out from a temporary platform which is fixed to the guide rails that have already been mounted and lifted up through the shaft by means of a block and tackle. The machine bed plate is assembled next. A comfort kit is standard supply for 1.6 meters per second, but optional, though highly recommended, for 1 meter per second. These low-frequency metallic cushions absorb any vibrations that the system may produce. The machine is fixed to its support and is lifted and guided into position with the help of a block and tackle. It is fixed to the sheave side with the fixings provided, and once the machine is level, these fixings and the clamp can be tightened. Once the machine is in place, the penultimate guide rail support and the last section of car guide rail fixed to the bed plate can be assembled. The dead hitch point can now be assembled, followed by the overspeed governor and the slack cable control device, should it be applicable. At this point, all the mechanical elements of the elevator are assembled in the headroom. All the guide rail supports must be placed in the positions detailed in the installation drawings. The position of the top and bottom brackets is of special importance. Any scaffolding and platforms should be removed at this point. It is now time to go into the pit. In the module FRM, we will find all the components relating to the car and counterweight frames and the buffers. The counterweight buffers should be assembled first of all in the position detailed in the installation drawings. Resting on its buffers, the counterweight frame is then assembled. A partial loading of the counterweight should then be carried out, according to the individual assembly requirements of each elevator. The car buffers are assembled next, in the position detailed in the installation drawings. Resting on its buffers, and on the car floor, the car frame is assembled. As an optional accessory, Witte offers a temporary protection to protect the car floor whilst the assembly process is taking place. The slings are now correctly assembled and positioned within the shaft and between the guide rails, and it is time to suspend the car slings in order to assemble the traction ropes. All the necessary material is applied in the module ROP. The machine should previously have been connected to the power with the encoder cable.
The car sling is then lifted with a block and tackle to the highest floor that allows the floor of the car to lie flush with the landing FFL.
Its position is maintained by means of the car frame locking kit. This element has not been designed to specifically suspend the car, but to fulfill the function indicated in clause 6431 of the standard EN 811A3. For the assembling of the traction ropes, please follow the instructions detailed in the elevator's installation manual. Repeat the process as many times as needed. A rope clasp guarantees the correct alignment of the ropes as they are fed into the grooves of the sheave. The next step is the assembly of the overspeed governor, its tension weight and the cable that joins them. The fixing of the overspeed governor cable to the frame is the last stage of this sub-assembly. At this stage, the elevator can be used as an elevating platform with the use of an assembly operating panel. The elevator must be handled with great care during these journeys. With the help of the elevating platform, the landing doors are assembled. Before starting the assembly of the car, it is essential to mechanically block the car frame and to remove the floor protection should it have been used. It is now time to assemble the car door. The pit components can now be put into place. The counterweight screen is fixed to the guide rails, and should it be applicable, the pit ladder is fixed inside the pit. From this point onwards, the electrical elements can be assembled.
The MRLW line controller, with its plug-and-play concept, is probably one of the market's most easy and intuitive controllers to install. It is delivered perfectly packed and identified in 4 packages: power and control, pre-assembled electrical installation of the shaft, electrical elements of the car, and the controller cabinet. In each of these packages there are various assembly kits, each one accompanied by a description of its contents and an assembly manual, numbered according to the assembly sequence. The controller cabinet, with its reduced dimensions, is placed neatly in front of the frame of the landing door located on the last floor. The simplicity of the controller does not reflect its features. The MRLW line controller can be supplied also according to other standards, such as EN 8170 and EN 8173. Upon request, it can also be adapted to the EN 8171 and EN 8172. Our pre-assembled electrical installation uses the CON-box system, which greatly reduces the assembly time, guarantees the quality of the CAN bus signals, and sets us apart from our competitors. The flat cable is manufactured with highly resistant and durable materials, which guarantee an optimal protection of the low-frequency CAN bus signals. An absolute positioning system of the car by means of a 4096 pulse encoder is optional. This makes assembly easier and guarantees millimetric precision of each stop. The penultimate task is the important one of cleaning the shaft and the pit, and of oiling the guide rails. Finally, before the lift can be put into service, the MRLW line must be submitted to a series of tests, according to Annex D of the EN 811A3, in order to ensure the perfect functionality and safety of the lift. VITA supplies a specific document which guides the assembly technician through all the steps that must be carried out. VITA has been issued by IONOR a conformity certificate, confirming the implementation and maintenance of a quality assurance system for the design, manufacturing, and final testing of elevators, and certifying that it complies with the requirements of Annex 1 of the Lift Directive 95/16/EC. This means that any assembly company with a quality assurance system compliant with the Annexes 12 Module E or 14 Module D of the Lift Directive 95/16/EC can put the lift into service and certify it accordingly. VITA can also supply the necessary documentation allowing any assembly company without a quality assurance certificate
the possibility of certifying the elevator through an external notified body according to Annex 6